In this video, we're going to be learning a complete pipeline for algo trading in Python. That is, we're going to start with the very basics of how to gather data, and we're going to take that all the way through to having a bot deployed on a cloud service, analyzing our trades and repeating and iterating over and over again so that we can get better at algo trading over time. This course is designed to be modular, so you can take each section pretty much individually. So you can mix and match whichever sections appeal to you most, whichever ones you'd like to learn more of. But pretty much throughout your whole algo trading career, you'll be following the same 5 or 6 steps that I outlined in this video. You'll just be making them more niche, maybe more advanced in some areas. But this course is designed to give you an overview of the entire process, and then you can swap out individual components for ones that more closely suit your needs. So let's dig into what exactly we're going to be talking about. We're going to start off with the data gathering process. This is probably the most important part of the process. If you want to do anything in algo trading, you're going to need to backtest your strategies. If you want to backtest your strategies, you need a source of data to compare your strategy against. In our case, that's going to be cryptocurrency price data, but for you, it could be historical bond yields, anything. The principles that we're going to be using in the data scraping section will be applicable across multiple domains. We're then going to use that to do some backtesting using a library called VectorBT. Again, an absolutely critical component of algo trading, so that you can see which strategies have performed well historically, and more so that you can get rid of strategies that are just not doing anything at all. Thirdly, we're going to be actually writing our execution code. So this is the code that actually sends the trade to the exchange when our indicator thresholds are met. Again, we're going to be writing this purely in Python, all the way from data scraping through to trade analysis. That's just to make things consistent throughout the course, and so that you don't have to learn 6 different languages. But there's no reason you couldn't swap out the execution code for something faster if that's what you needed. Again, that's why we're doing this in such a modular format. So number 4 will be deploying the bot to the cloud. I'm going to be using DigitalOcean to just rent a cheap VPS, but you can also use something like Amazon or Azure or Google Cloud. The process will be pretty much the same for deploying our Binance crypto trading bot. And then finally, we'll be looking at some analysis of our trades, maybe some points for improvement that you could take on as a learning exercise to enhance this bot and make it even better, to enhance this basic framework that we have here for algo trading, and to make it into something that could really work for you. If you want to check out the text version of this tutorial, or you want to get in contact and build some cool stuff in Python with me, you can check out the link to the blog in the description at greyhoundanalytics.co.uk. And without further ado, let's get started and begin our algo trading journey in Python. In this section, we're going to be gathering data that we can use to backtest our strategies and to figure out which ones work, which ones don't. And the format that we're going to be getting that data in is going to be in CSV format. We're going to be getting open, high, low, close volume data, or in other words, just the candlestick data that you see when you're looking at the charts on any major exchange. Speaking of exchanges, the exchange that we're going to be scraping this data from is Bitstamp. They have a freely available open API that you can connect to, and you can request candlestick data for any of their different pairs of currencies. And even if the currency pair that you want isn't available on Bitstamp, you'll be able to use the principles that we've developed during this section here to make your own downloading script for something like Binance or Kraken or any other major exchange really. The principles are very much the same. If you wanted to quickly just get started and skip this section, go straight to the backtesting, you can go to cryptodatadownload.com and just download some CSVs from there. Obviously, that might not be the most up-to-date information, and they might not have the currency pair you want, but it's worth a try if you're just interested in the backtesting portion of this video. Once we've got all this data, we'll be able to create something like this, which is a heat map showing us which entry and exit points yields the best total returns and allows us to avoid pitfalls in setting parameters. And having a script like this will let you reuse it over and over again to download different currency pairs and test your strategies against them all. If you want to just grab the code or you prefer to see it just in text format, you can check out the blog post in the description where I have it all laid out there, just for easy copying and pasting, and that'll be more up to date if there are any minor changes to the API or that kind of thing. So with that, let's get started and start gathering some data. We're going to start off by creating a new environment in this folder here. So I use virtual env. Your editor might have this functionality built in. Maybe if you're using something like PyCharm or Visual Studio Code, they will separate the environments themselves. I'm just going to use virtual env because I find that easiest to use. So I'm going to create a virtual environment here where we can install all of our packages that we'll need. So you just do source venv bin activate. You can follow along in the command line section of Visual Studio Code or something like that if you've got that installed. So now that we're in our virtual environment here, you can see on the left hand side here, let's go ahead and just open up a Python file. So we'll call it tutorial.py. Now we're going to need some packages here. So I'll just list them all out so that we can get them downloaded. So we're going to need JSON. That just is bundled with Python. You don't need to install anything for that. We're going to import requests. Requests is a library that's used to pull information from a website. In our case, from the Bitstamp website. So very important module. We're going to import pandas as PD. Very common data science module. We're just going to be using that to keep everything in a nice data frame. And then finally, we're going to want to import date time, which is installed with Python. So essentially, we need to install pandas and requests. So let's do that now with pip. So pip3 install pandas, and then pip3 install requests. Now that we've done that, let's open up our Python file again and start downloading some data. So if you go to Bitstamp/API over here, so bitstamp.net/API, you'll find this, which gives you the documentation. If you go down to open, high, low, close data here, we can see the documentation for open, high, low, close data. So this is the URL that we're going to be connecting to here. So if you just copy this URL, let's go into here and we'll just give that a name. So we'll call that URL is equal to this. And then we'll need to put that in strings. And then we'll want to set this currency pair variable here. So if I make that an F string and then I say currency pair, let's go back to the website. We can see that BTC USD is allowed. So let's use that one. Is equal to BTC USD. The F string here will make sure it's automatically put in place. So that's great. Let's have a look back on the website to see if we need to include any parameters. So the start and end parameters here seem to be optional, so we don't need those. What we do need is we need a step parameter. So that tells us what sort of time frame that we're after in seconds. So you can get minute data, 3-minute data, 15-minute data, so on and so forth. So let's include that as a parameter. To do that, what we do is we create a Python dictionary. So we'll just say params is equal to, and then we'll start a dictionary. And we'll say step is equal to 60 for 1-minute data. And then we also had to set another variable called limit. And that's just the maximum amount of bars that it will return. I'm going to say 1,000, just a large number. That doesn't matter too much for our purposes. And if we put that through requests now, that should give us some open, high, low, close data. So let's have a go and see what happens. So in order to get that out, we'll say data is equal to requests.get. Then we'll put the URL in and we'll say params is equal to params. So we're going to set our parameters, and then let's print out data.json. So we're going to turn that request into a JSON format and then print it out. So let's see what happens here. This is looking good. We've gotten something that looks JSON-like, and we've got open, high, low, close data. Let's just set the limit here down to 10 temporarily, just so that we can see everything on one page. So here we go. We can see that this is actually a set of nested dictionaries, basically, and the actual open, high, low, close data is buried a few levels deep. So let's go ahead and just drill down into this. So the first level here is data that we need to index into. So let's go down here and we'll say data, run it again. So the next one is OHLC, so we'll dig into that. OHLC. And then we've now just got a list of bars, basically. So you can see each one of these dictionaries here in curly brackets basically represents one candlestick on a graph. So you've got your high, volume, low, close, open. You've also got a timestamp here. So this should be the number of seconds since the 1st of January 1970. It might also be in milliseconds, but we'll find out. So it's essentially the amount of seconds since the epoch time. It's just how computers measure time. We'll convert this into something human readable in a minute, but for now it's just important that we actually scrape the data. So to make this a little bit neater, let's convert this to a pandas data frame here. So instead of this print statement, we'll just assign data to this. So we'll set data equal to that value. And then we'll say df for data frame is equal to pd.data frame. So we'll create a new data frame and we'll give it that data. Then let's go ahead and print out df, and that should be a nice data frame. So this is a lot nicer to look at than this thing. So that's just why we're using data frames here and why we're using pandas. So if I grab this timestamp here and I put it into Epoch Converter, this nice website, we'll be able to see that this corresponds to the 11th of January at 2 minutes past 10. So at the minute, it's just grabbing the previous lot of 10 minutes. So you can see it's currently 13 minutes past 12. So it's just essentially grabbing the previous 10 bars. Now, you can set the limit here to be a very high number, so say 1,000. But at a point, it will refuse to give you any more bars. So we can come through here and we can say it's a maximum of 1,000. So 1,000 minutes is, it's not that long. It's not even a month's worth of data. And if you're wanting to scrape years and years and years of data, this isn't going to be too helpful. So what we need to actually do is we need to make multiple requests if we want to scrape long-term data, especially on these shorter time frames. If you're just trying to scrape daily data, then maybe you can just do this in one request, but it's nicer to look at how to do multiple requests anyway, so I'm going to show you how to do that. So what that will involve is essentially wrapping this whole thing in a for loop and using the start and stop parameters here. So let's go ahead and implement that. So the first thing we're going to want to do is we're going to want to generate these start and stop times. So we're going to want to have sections of time. So say I want to request all the data for the 20th of March, then the 21st of March, then the 22nd of March, so on and so forth. How do we do that? Well, there's a really nice function in pandas called pd.date_range. So this will do what it says on the tin, basically. It will produce a range of dates in date time format that we can convert to an integer, convert to a number. So we'll convert between human readable format and computer time, and then we can plug that into our request to Bitstamp. So all you do is you give it a start date and an end date. So I'm going to say start is equal to 2021, say 0101, so the 1st of January. And the end date is going to be 2021 0102. Pandas uses year month, day format. So do bear that in mind. Depending on where you are in the world, it might be slightly different. That's just how Pandas does things. So remember to keep things in that format if you can. Then let's pass in the start time, the end date, and then you want to pass in the frequency. So we can say frequency of 4 hours or 10 minutes. So T is minutes in this case. You can give it whatever frequency you like here, and it'll come up with some date time stamps that you can show. So I'll just do 1 hour here, just so that we can see what's happening. So 1 hour, and then I'll print that on out. So print dates. So we can see over here, between the midnight on the 1st of January 2021 and midnight on the 2nd of January 2021, it's produced these timestamps at every single hour interval. So we could plug that into our request here to request the minutely data for every single 1 hour interval in this range. That's essentially how we're going to do these multiple requests. In order to convert these to integers here, all you have to do is reassign the value of dates here. So we'll say dates is equal to, then we'll do a list comprehension. So we'll do x.value for x in list dates. So we're going to convert dates to a list from a date time index weird pandas option. And then we're going to get the actual integer value of that date. So we'll see what happens when we print it out. Now, what you'll notice is that these numbers are huge. And that's because by default, Pandas measures time in microseconds, I believe. So in order to convert, we just have to divide by 10 to the 9. So we just have to divide by 10 to the power 9, and that should do the job. So you can see this gives it as a floating point number here. So it's got point something, whereas the Bitstamp parameter takes a integer. So we'll have to convert that to an integer. And so what we've done there after a lot of cajoling is that we've got these 1 hour time frames here. So between this and this, there's 1 hour. Between this and this, there's 1 hour, so on and so forth. And so we can now do our multiple requests using these start and stop parameters. To do that, we're going to wrap this bit up inside a for loop here. So what I can do is I can say for first, last in zip dates and dates 1 to the end. So what this will do, and I'll print it out just to show you what's happening. So we'll do print first last. So what this does is it will take each element and then the next element, and it will give us that on each iteration of the loop. So on the first iteration of the loop, we just get the 0th element and the first element. Then on the second iteration of the loop, we get the first element and the second element. So you can see this one is the same as this. This is the same as this. This is the same as this. This is the same as this. So it just basically gives us the pairs as we go along. So if we were to convert this to human time, this is between midnight and 1 a.m. This is 1 a.m. to 2 a.m., 2 a.m. to 3 a.m., so on and so forth. That's how this is working here. So it gives us our time intervals, which we can plug in to the Bitstamp here. So let's just indent all of this, basically, all the stuff we've done so far. And then we can add in our start and stop parameters. Start is going to be first, and then stop is going to be last. Let's just check that against the API here to make sure I've got it correct. So it's actually end there. And then if we just let this go, let's see what happens. So we can see it's doing a lot of different requests here. It's gathering 1,000 rows every single time. And the quick-witted amongst you might have noticed that there's not 1,000 minutes in every hour. So each interval we're getting here is an hour, and yet we're getting 1,000 rows. That's just the way these parameters work. What we're actually doing is we're gathering slightly too much data here. So this 1,000 bars of data here lies well outside our 1 hour time frame. And you can see that by just checking some of these timestamp here. So I'll check this one. If I go to Epoch Converter, this one is 7:21 AM. Let's check the other one. So at the bottom of this list here. This one's going to be midnight exactly on January the 2nd. So you can see it's including a lot more data than we initially asked for. But it's fine to have too much data, we just don't want to be missing any data. So that's all well and good for now. So what we're going to do is we're actually going to create a list over here. And so this list is going to be called master data. So that's just going to be a main list that contains all of the data so far. We're just going to make that an empty list. And on the end of each iteration here, we're going to say master data plus equals data. And then we'll not include this here. So this data frame is going to go afterwards. So it's going to be outside of the loop. And that's going to actually take in master data. So if we just let this run again, we can see it's checking all of the 1 hour intervals. And then in a minute or so, when it finishes, we'll have this huge list with 24,000 rows, which is just all of the data we've gathered so far. What we want to do now is to just trim out the duplicates. So remember, we're actually gathering more data than we need. So let's go ahead and just trim the duplicates out. Thankfully, Pandas has a really nice, easy function for this. So we'll say df.drop_duplicates. Let's just run it again. So you can now see we're down to 2,380 rows. Again, this is only 1 day's worth of data, so there should only be 1,440 data points. So as we can see, some things gone awry. So what we can do here to just smooth things out is we can remove the data that's outside of our time frame. So we only want data, in this case, between midnight on January the 1st and midnight on January the 2nd. So how do we go about clearing that out? Well, the first thing that I'm going to do is I'm just going to make sure that the timestamp column is actually recognized as an integer. Sometimes when you're downloading data, it gets recognized as a string. So Pandas thinks it's a string. We want to just make sure that Pandas understands that it's actually an integer. To do that, you just set the column equal to the column.as type, and then you select int. Once we've done that, we can sort the whole thing. So we'll say df.sort_values by equals timestamp. Make sure that you've spelt your column name correctly. And then when we print this out, everything should be in order of time. So we can see here, if I grab, say, this one, let's see what time this is. This is midnight, so this is correct on this side of things. On this side, however, I suspect this will be before our starting date. Yeah, this is on the 31st, so we want to remove some of this data. To do that, pretty easy now. We can just apply a filter here, just in Pandas. So we'll say df is equal to df. Then you want a pair of square brackets. And then we'll say we want all values where the timestamp is greater than or equal to the first entry in our list of dates. Now, once I run this, that's basically us done here. Now, the reason why we've got 1,441 rather than 1,400 is because we've actually included the candle at midnight, which, this is personal preference. I'm just going to remove that using this. So I copy the line above, and we just want things to be less than our final time there. That's just personal preference. It's up to you. So this script is pretty much ready to go at this point. You can tune things to how you like it. So you can change the currency pair as on the Bitstamp list here. So we've got plenty of different currencies that you can check. You can also mess around with the frequency here. So 1 hour, you could probably bump this up to 6 hours. This just means you have to make fewer requests and the data downloads quicker. And most importantly here, you can mess around with the start and end times. So I can change this to the 5th of January here and watch it go. So that's just gone ahead and downloaded me all of those data in those 5-day regions pretty easily and minimal effort. To save this down to disk here, pretty easy, it's just one line. So if I go down here, we just do df.to_csv, then the name of the file that you want to save it down as. So I'll call mine tutorial.csv. And then I usually use index equals false. You can try it with or without. It basically just gets rid of the numbers on the side, so the row numbers. That's all that option does. So if I run this, I exit out of here, and I look in our tutorial.csv file, you can see we've got our high, timestamp, volume, low, close, and open data, all here in this nice CSV file, which we now can use for our backtesting. So this is just a really handy script that you can keep using over and over again in your projects to get whatever data that you need from Bitstamp for a variety of different cryptocurrencies, pretty much as many as you can need to do all the backtesting in the world that you desire. Free of charge, you don't have to pay some company extortionate rates for data that's free anyway. So with that, let's head on to the backtesting section of this video, where we'll learn how to actually use this data to optimize our parameters and our strategy going forward, so we can plug that into our bot and make more optimal trades. In this section, we'll be going through and backtesting our strategy to make sure that it's performed well historically, and we'll also be doing some hyperparameter optimization. That is, we'll be looking at what is the optimum entry and exit points for our strategy. Our strategy is going to be based on just a simple RSI strategy. So the traditional one is buy when the RSI is 30, sell when it's 70. We're going to do some optimization to see exactly where we should set those buy and sell points in order to achieve maximum gains for a specific symbol, at least on a historical basis. So the tool that we're going to be using here is going to be VectorBT, which is an up-and-coming backtesting library. It's sort of a challenger to Backtrader. I think it's pretty cool. It's very, very, very fast in what it can do, and it's got some really easy-to-use visualization options, so you can very quickly see what's happening with your trades and how a particular strategy is doing. And it's well integrated into Plotly to do things like heat maps. So you can feed in your entry and exit points and just use the default plotting options, and it'll give you a screen like this where it shows you each and every trade, how well they did on a returns basis, the cumulative return versus the baseline level, as well as each and every single one of your orders, so both entries and exits. I'll show you how to do this in a minute. It's literally a couple lines of code. And then finally, we'll be going on to our hyperparameter optimization heat map here. So this is the strategy I was talking about earlier. So this is the exit point. So at what point are we going to get out? So when the RSI gets to 80 or when the RSI gets to 60. Similarly, this over here is going to be our entry. So you can see here, roughly a exit of 60 and an entry of about 25 seems to be optimal, at least for the particular data set that I used when I was running this earlier. You can see that the heat map is symmetrical across this axis here, so you only really need to pay attention to one of the quadrants. So with that, let's create our strategy, backtest it, and do some optimization with VectorBT. Now, the first thing that we're going to do is we're just going to go and sort out our virtual environment here. So I'll get rid of my old virtual environment and we'll make a new one. So we'll go in here and we'll say virtual env venv. Let's activate that, source vnv/bin/activate. So we're going to want to install a few packages here. I'll just list them out ahead of time so we can install them. We're going to want to install pandas and VectorBT, essentially. So let's install pandas, pip install pandas. And then we'll go ahead and grab VectorBT as well. So that's gone and installed now, and you may have noticed that we got this error here. So this occurs a good percentage of the time. Basically, the version of NumPy is mismatched here. So Number, which is like a just-in-time compiler, has the requirement of a certain NumPy thing, but we don't have the right version. So the way you fix this is you just install a specific version of NumPy. So let's install 1.2.0, since that seems it meets all these requirements. So we'll do pip3 install numpy equals 1.2.0. I think 1.20. And that should fix some of our problems. If you don't install a specific version of NumPy, sometimes it will mess up. That may be fixed by the time you're watching this tutorial, but it's just something to watch out for. So that should be everything installed, basically. The next thing that you'll want to do is to go ahead and just grab some data. So if we go back to our data gathering folder here, you could open up our tutorial file, and you can set this to whatever time range you feel like. So maybe I want to gather a month's worth of data. I could do something like that. So it'll gather everything from January of 2021 for Bitcoin USD. We could do ETH USD, various other options. I'm just going to use one that I generated earlier. So it's this one called data.csv. I'm just going to go grab that and put it in our backtesting folder here. We can get rid of this old one here. And I'm just going to rename it to btcusd.csv. Let's open it up, check that we've got all our data in there. So we've got the index here, which I'm just going to get rid of. And then other than that, everything looks fine to me. Let's close that out. And let's open this up in pandas. So we'll do vim tutorial.py. So just open up a Python file. Let's just get everything imported so it's out of the way. So we'll import numpy as np. We'll import pandas as pd. We'll import datetime from datetime. So from datetime, import datetime. And then we'll import VectorBT as vbt. Okay, so that should be all the importing that we need to do for now. Let's grab that data set that we had there and just get that as a pandas data frame that we can use. So we'll say btc underscore price is equal to pd.read underscore csv. And then we'll say btc usd.csv. So just make sure it's in the same folder. If it isn't in the same folder, make sure you provide a file path to it in that string there. And then what we can do in these double brackets here is we can provide the column names that we want to select specifically. So I don't need the full open, high, low, close. I'm just going to backtest with the close values. So all I want is timestamp and close. And if I print out BTC price here, we should be able to see that. There we go. We can see we've got timestamp and close in a nice data frame. So that we can actually read the date, let's make the timestamp column into one that's human readable. So we'll create a date column here, date, and we'll set that equal to pd.to_date time. And then we'll just feed in the timestamp column here. And then that should be good. So if I say BTC USD, let's see what happens. Spelling error there. Sorry, BTC price. You can see what's happened here is all of these dates are in 1970 and they're like a few seconds after the epoch time. All that's happened there is that Pandas is assuming that we've input our timestamps as nanoseconds when ours are actually in seconds. So that may be different depending on which exchange you got your data from, so make sure to check that. But you can mess around with the unit here. So you can say unit equals seconds, or unit equals milliseconds, or unit equals nanoseconds. Whatever it happens to be for you and the timestamps that you have. I know that mine are in seconds, so when I run this again, we'll have the actual time here. So this is running between the 1st and the 9th of November 2021. That's just a particular data set that I used. You can scrape this data for yourself if you want to use the same data set as me. Now that we've got that, let's dig into some actual VectorBT code here. So we'll just set the index here to be the date. That just makes things a little easier for us. So we'll say BTC price is equal to BTC price dot set underscore index, and then we'll set that to be date here. So if you print this out again, we can see that all that's happened is we've gone from having a numerical index here, so it just counts the row. Now the row is labeled by the date at which it occurred. Finally, we just get rid of this timestamp here. It's not useful to us anymore. We have the dates in a human readable format. So to do that, all we have to do is just select the close column here. So if I just run that, we've now got our data in the format for VectorBT that VectorBT really likes. If you're using VectorBT, this is typically how you're going to be wanting to test things if you're doing single sim. If you want to test multiple stocks at once, you can do that, and your Pandas data frame will look a little bit different, but we're not going to dig into that in this particular video. Let's go ahead and calculate the RSI here. So remember, our strategy is an RSI based strategy. So let's go ahead and calculate the values of that. So RSI is equal to vbt.rsi.run BTC underscore price. Window is equal to 14, and we'll give it a name. So short name is equal to RSI. There are lots of different indicators just built in to VBT here. So I believe you can set this to MA for moving average, probably EMA for exponential moving average. That lots of the basic indicators are built in here, so you don't have to calculate them yourself, and so that VectorBT can vectorize them and calculate them extremely quickly, as it has been doing for us so far. The next thing that we want to do is we want to define our entry and exit points. So let's make a table here, and we'll call it entries, and we'll set that equal to RSI dot RSI underscore crossed underscore below. You'll see what this looks like in a second, so I'm just going to put a number in there, let's say 30, just for our traditional RSI strategy, and I'll print out the value of entries so that you can see what's going on. So all that's happening here is it's gone ahead and calculated the RSI at every single point. So you remember we had our RSI variable that we created, and then it goes through and establishes where in time the RSI has crossed below the value that we picked. So we gave it a value of 30. So it's going to look where in time has the RSI crossed below 30. Evidently in all of these particular time periods it's false, but there will be some true ones in there. If you want to find them, you can probably do something like print out entries.to underscore string. And if you print that out, it'll print out the full list as opposed to just printing a few of them. So you can see here we had a crossover, here we had a crossover, here. So it happens fairly often. So we've got our entries, now we just need our exits. So our exits are going to be very similar here. So exits is equal to this same thing here, except we're going to want to have crossed above. And we're going to want to change our number here. So we'll change that to 70. I'll not print it out because you get the idea. And so the next step is basically the final step actually in just simulating this simple example here. So if we say put PF for portfolio is equal to VBT dot portfolio dot from underscore signals, then we give our price data, so BTC underscore price, and then we give our entries and our exits. What that does is it goes ahead and actually simulates the portfolio. So if you'd actually gone through and you'd exited on these points and you'd entered on these points, given the price values here. In order to actually observe any information here, what you can do, well, you can do a few different things. So we can print pf.stats. So let's try that first. From signals, not from signal. So once that's gone ahead and simulated everything, you should get a printout like this. It can take a couple of minutes depending on how much data you're actually pushing through it, how small your time period is, etc., etc. So with this simple stats printout here, you can see our total return is 3%, benchmark return is 9%, so our strategy didn't really do very great at all. Our win rate is 65%, but we seem to be losing more on our losing trades than we're winning on our winning trades. And this is without even commission and things like that. So evidently the basic strategy didn't work in this time period. But that's what our hyperparameter optimization is for. If you want to get the plot up, you can just do the same thing here, except instead of printing pf.stats, you just do pf.plot.show. That'll open up a new web browser here. So just open up a new tab in your preferred web browser. And this is just a regular Plotly graph basically. So you can do everything that you would normally do in the Plotly library. You can see each and every one of your orders, how much you bought, what price you got, and the trades here, whether they're winning, losing, by how much percentage. Just a really nice starter graph here. You can customize this basically to your desire. You can plot any value that you want. Again, we're not going to get into that in this tutorial because it would be a whole video of its own and what I'll maybe do in the future someday. So getting back to our code over here, we've got this very simple strategy, but it is somewhat boring to say the least, right? It's not one of these tasty looking heat maps that I showed you earlier. So how do we go about doing that? Well, firstly, you have to pick the parameter that you want to optimize. Now, you could do things like you could optimize the window length here if you wanted to, but in my case, I'm just going to optimize for these entry and exit points. You can go back afterwards and plot out different window lengths and see which one performs best. Generally speaking, you don't want to optimize more than 2 variables at once if you're going to plot them out. So if you've got 2 variables, you have a 2D graph. If you have 3 variables, you've got a 3D graph. So that'll look like maybe a cube or something. You can optimize more parameters, but you're not going to get a nice graph out of it, is what I'm saying. With that aside, let's produce a evenly spaced array full of different possible entry and exit points. So we'll use NumPy to do that. That's why I imported NumPy at the beginning. So we'll say entry points is equal to np.linspace between 1 and 45. So those are going to be our possible entry points. And then we want to select a number. So how many evenly spaced values between these do we want to have? So I'm just going to say num is equal to, I'll just say num. And then we'll provide a num value here. So we'll say num is equal to 10. And we'll put that at the beginning here, just as like a config section. So we'll do the same thing here, except with exit points. And that's going to be between 55 and 99. So already what we could do here is we could add in our entry points and our exit points. This is the simple way of doing it, and we'll come back later in the video and we'll add something to this to give us more options for optimization. What this will essentially do here is it will compare each value in entry point with the same value in exit point. So for example, let's say the first one is 1 and the first one in here is 55. The first one it will test out is 1 and 55. The second one might be 3 and 57. So it's not going to test every possible entry and exit, but it will test a few of them against each other. I'm just doing this to save complexity for now so we can quickly get to our visualization. So the portfolio generation is going to be the same as before. So we've just got this line here. And then we're going to want to grab some metrics from this. So let's define a metric. And we'll say that's equal to total return. And we'll actually put this at the top of the file here. So it's just more like a config. And then we'll go ahead and grab those metrics from each portfolio. So if I do pf_perf, so for performance, is equal to pf.deep.get attribute metric. So essentially what's going to happen here is it's going to go into each portfolio contained within here and grab the prescribed metric. There are certain rules about how you feed in the metric depending on what kind of metric it is. You'll want to look more deeply into this function if you want to know that. I'll show you a few examples later on, but for now we just need to know that what this is doing is going and grabbing the total returns from the different portfolios. We should be able to just print it out here and we can see what it looks like. So I think we just have to convert these numpy arrays here to lists and this will be fine. So if you just wrap the list around that. And of course, the deep get attribute function is not from pandas, it's from VectorBT. So it's pf.deepGetAttribute. So that should be all fixed now. Let's go ahead and run it a final time. Hopefully no errors. So we can see here, it's gone through each options that we have. So this is the RSI below. So this is the lower threshold. So a lower threshold of 1 and an upper threshold of 55 gives us no return. Presumably that's because it hasn't done any trades. Whereas an RSI below of 15 and an upper of 69 gives us a 4% return. So I hope you're getting the idea of how this script is working so far. Just to recap, what we've done is we've created a list of evenly spaced entry and exit points. We pass that into our entries and exits functions here as a regular Python list. We pass that to our portfolio from singles function here, just normally. And then this function goes in and grabs this attribute for each of those simulated portfolios. Now that we've done that, we're almost ready to plot the heat map here. We just have to use one more function to transform the data. So we'll say pf performance matrix is equal to pf_performance dot vbt dot unstack _to df. Now we have to provide a few arguments. I don't think it matters too much which order this goes in. So we'll say index_levels is equal to RSI_crossed above. So all I'm doing here for these values is I'm just copying in these column names here. So that's where these strings are coming from. So if I go back, we'll say index levels is equal to RSI crossed above, and then column levels is equal to RSI_crossed below. And then if we go ahead and print it out, we'll be able to see what's actually happening here. So as you can see, what that long and complicated function has done is it's turned this into a data frame. So this just makes it easier for the heat map to plot it. So you can think of each one of these squares as a pixel in the heat map. And so it just has to plot these values basically. That's all that's gone on. It's just created a grid of the below values and the above values, and then in the associated grid, it plots out the return. So we only calculated the return for a few of these values. So when we plot the heat map, it'll only have a few of them. Don't worry, I'll show you how to correct that after we're done. So finally, we can just plot the heat map. So we'll say BF underscore performance underscore matrix dot VBT dot heat map. And then we'll just label it X and Y axis here. So X axis underscore title is equal to exit, and Y axis underscore title is equal to entry. And then finally we call dot show on that. So all being well, this should pull up a nice heat map. There we go. Now you can see this looks very different from our earlier heat map, but it is testing a few different options at least, which is what we want. I think our X and Y axis are the wrong way around here, but don't worry, I'll correct that in a second. So you can see that when we have an entry of 25 and an exit of 79, that returns 4%, all these different values. So let's just fix our axes here. So we'll go back. And the X-axis is going to be the entry, and the Y-axis is going to be the exit. Beautiful, that's a little bit nicer now. So let's go ahead and fill in all these other squares here. So we're only currently testing this diagonal line basically. And so what we're going to have to do for that is we're going to have to produce a list of lists. And within the inner list is going to be a pair. So it's going to be, 0 and 55, 0 and 60, 0 and 65, 0 and 70. Then on the next lot, we're going to have 10 and 55, 10 and 60. That's the rough outline of things. Now, in order to actually do this, what we're going to use is we're going to use numpy.meshGrid. Now, you may have never come across this before, neither had I, but this is just a nice code snippet that will help you produce these kinds of grids. So we've got our entry and our exit points here. What I'm going to do is I'm going to create something called grid, and I'm going to set that equal to numpy.meshGrid. Then we'll pass in entry points, and exit points. And we'll print that out. So we ignore our diagram here, and let's have a look at what's happened. It's basically just produced this big grid full of all the different linear space options that we put in there. If we transpose it here and reshape it, you'll see what's actually happening. If I run it again. Of course, we have to convert to a numpy array if we want to transpose it. So numpy.array. So there we go. You can see what's actually happening here. So it's taking each value and then combining that with the other list. So you've got 1 and then all the possible combinations. And then you've got 5.8 and all the possible combinations. So it just takes every possible combination from those two lists that we have. So you can see originally we had 1, 2, 3, 4, 5, 6, 7. We had 10 numbers, didn't we? Because I said num equaled 10. So this should have generated about 100 different options because it combines each one with every other option. And that will help us fill in all those squares on the grid, with this side here being our entry points and this side here being our exit points. I wouldn't worry too much about this higgery-jiggery pokery over here with the reshaping and transposing. The point of this line of code is to take every possible combination of these two lists. That's all you really need to know. So now that we've done that, we just need to actually extract the entry points and the exit points from grid here. Now, in order to do that, we can use slicing here. So we can say grid, and then we open up our square brackets. You do colon, comma, and you pass in the column that you want to grab. So in this case, for the entry points, I want to grab the first column, so the 0th column. And then for the exits, I want to grab the first column. So the column number 1. I'm just going to comment all the rest of this stuff out, just so I can show you what's happening here. So if I print out grid, and then I print out grid, but I'm going to slice into it. So we'll say colon, comma, and then we'll pick the first column here. Just so you can see what's happening. So here is grid. So this is the pairs of different values with our entries on the left and our exits on the right. It's a list of lists, right? So each list contains many other lists. All I've done is I've just grabbed this first set here. So this line, basically, this left-hand column, I've just grabbed those, and that's now in its own list of lists. That's all that's happening here with this fancy slicing notation. So I'll uncomment the rest of everything now. And if I'm not mistaken, everything else should just work fine. All we've done is pass in some new entry and exit points. Nothing else should set on fire. So let's see what happens. It wouldn't be a Python tutorial without a few syntax errors, so let's correct that. You can see all of the different combinations here we have in this nice collection. I think to get the exact graph I had before, you have to select symmetric equals true. We'll see what that draws. So each item here is just color coded by the total return. So the lighter the color, the higher the total return, and the darker the color, the lower the total return. Now, in this particular case, what seems to have happened is that there was a trade where you could buy and then sell at 99 RSI. And so this would be an example of us not having enough data. If you were to actually try this strategy in the real world, it wouldn't be amazingly effective. I'm just going to go grab some more data and plug that in, and we'll see what it optimizes to. So pretty easy now that we've got all our tools in place. Go back to our data scraping section. Let's get rid of this one. I'll go ahead and just run our script here. There we go, that has downloaded all of our data points for us. I'll just go ahead and copy and paste that into the right folder. So if I go let's grab that, and we'll put it in the backtesting folder, and we'll save it as BTC USD. And then let's rerun our backtesting script. So you can see here, once we used more data, so this is 2 months worth of data, we actually start getting a reasonable looking optimization here. I'm going to get rid of the symmetric equals true because it actually looks way better without it. So if I just get rid of this here, symmetric equals true, we don't need it. You can see that the optimum point here is looking like it's going to be roughly an entry point of between 20 and 25 and an exit of about 80. Now you could repeat this whole process again, and you could just do something like a much narrower range. So instead of going all the way from 1 to 45, you could try maybe from 20 to 30. And instead of going from 55 to 99, maybe you go from 70 to 85, something like that. Maybe 75 to 85. So if I do this again, we'll get an even more condensed view of the hyperparameter optimization. So you want to be careful not to overfit, not to over-optimize. And again, we're only plotting total return here. So there might be some other things that you want to optimize. such as the win rate or the drawdown. So I'll just show you how to plot those as well. So let's get out of this graph view. And we'll put our normal values in here. So 1 to 45 and 55 to 99. So if you want to plot a different metric, you just have to change this value here. Now, knowing what to write as the metric is, a bit difficult in this library. It's not made super clear in the documentation. But a few I've figured out, we can check the win rate with this. So you can do positions dot win rate. So if you use that, we should have the win rate plotted here on this optimization. Maybe you want to optimize for that. So you can see here we probably don't have too much information, but some of them have a win rate of 1 because there's only one trade. So obviously you want to think carefully when you're looking at these kind of things. We can also plot things like the max drawdown. So in order to do that, just because the way the getAttribute function works, you have to put it in a tuple because we're actually calling a function here. So you can put the max underscore drawdown. And that'll give you the max drawdown on the portfolio. Again, you want to backtest this with more data here. So we've got 0 trades in this column, so nothing's happened. So obviously this has the least drawdown. And of course you can use just the simple graph that we looked at earlier. So you can drill into any portfolio. So any one of these options, you can pick the parameters and then you can drop it in here and look at actually how it did on a trade by trade basis. That kind of versatility is what makes this library really cool. If you're feeling adventurous and you want to increase this, you can just for more granularity, but it will take absolutely forever to calculate and it may or may not run out of RAM. If you want to look into more metrics that you can choose here, so these metrics, you want to look into like this on this function here in the documentation, this deep get attribute, and just see what kind of attributes you can get out of the portfolio. Again, that's not amazingly well documented. You'll just have to experiment for yourself. But you can look in some of the notebooks that are released with the IPython notebooks that are in the documentation, and you can get a few ideas for how you can get these metrics out. But as far as backtesting goes, and a bit of hyperparameter optimization, that's pretty much everything I've got to show you. I've shown you how we can take our entries and exits, how we can make a grid of every single possible combination to test them against each other to optimize our particular problem. You could do the same thing over here with the window. You could run loads of different windows, maybe against your entry point, once you've figured out exactly which one you want to use. VectorBT makes it very easy to do that because you can often just pass pure Python lists into these functions and they work just great. I guess the clue is in the name, VectorBT. So now that we've got this, we're ready to actually start creating our bot, hooking it up to an exchange, and actually forward testing our strategy in the real world to check that we haven't, overfit the backtest and that the strategy actually works. And if it doesn't, we can always go back to the drawing board and run some more backtests on different samples of data. So with that, let's get developing our bot. In this section, we're going to be actually building our bot and implementing our strategy, which we've just optimized in the previous 2 sections. We're going to be trading on Binance. It's one of the most popular crypto exchanges and available pretty much everywhere in the world. You don't need a Binance account to do what we're going to do in this video because we're going to be trading on the testnet. So you don't need a live account. If Binance isn't available in your country, you'll still be able to follow along with this video and use the principles that you learn to adapt it to whatever exchange you're going to be trading on. We're not going to be doing things like booting up a database on the server, downloading WebSocket data to it and then extracting from that database. That's a more advanced technique and does give you better execution times and you can more quickly react to market moves. But it also takes a lot more time to develop, and it would probably be a 2 to 3 hour tutorial on its own to get that sort of system set up. In this video, we're just going to build something simple that will get you started in roughly 150 lines of code, and pretty much anyone can do it who knows a little bit of Python. As always, you can check out the blog post for extra bits of detail if something isn't quite right. Usually I'll post corrections on there and that kind of thing. So without further ado, let's get started and actually start building our bot. So the first thing I'll do here is just give you a brief look at what the bot looks like on disk, like how it's actually set up, what kind of files it produces, and that kind of thing. So we've got our bot here, just a regular Python file. We also create a bot account.json. So if we're looking here, it's just a regular JSON file. And all this does is it keeps track of whether the bot is currently buying or selling, and what assets the bot currently owns, like how much Bitcoin has it bought, how much Bitcoin has it sold, and that kind of thing. We do this because we want our buying logic to be very, very simple. So all we want our bot to do is we want to buy when the RSI gets to a certain level. We then want to stop buying until it reaches our sell point and then sell. If we didn't implement something like this, it would keep continually buying every time we cycle through. Every time it checks the RSI, it would just keep buying and buying and buying. We just want it to buy once, hold to the sell point, and then wait until it can buy again. So that's all this file does. We'll be going through how to generate this later on. We also have a logs folder here. Something like this is really useful for catching any errors that occur in your bot. So again, I'll be showing you how we can print out errors to the log here, and then you'll be able to catch them and fix them later on. Otherwise, it can be really frustrating if something's going wrong with the bot, but you don't know exactly what. And it'll also list all our trades in here as well as the timestamp. And then finally, we've got a trades folder here, which just details basically all of the trades. So what sim did you buy? What side was it buy or sell? How much in dollars? And then the price that was paid here. Obviously, these are the wrong way around at the minute, but we'll fix that when we get into the code. We also have a .env folder here. This contains our API keys here. So these are for the testnet, so we don't have to worry about anyone doing anything malicious with them. We'll be using a Python module called Python decouple here, and that will let us import these straight into our script. The reason why we do this is if we wanted to push this to GitHub, say our bot code, we really don't want to be also pushing our API keys, just in case someone else were to get access to the repo, say we wanted someone else to work on it. They'd also get our API keys, which isn't great. We much prefer to keep our API keys local to our host machine. So, with all that being said, let's go ahead and actually get started here. So I'll just delete our logs and trades folder, as well as our virtual environment here, just so I'll show you how to re-download all of the modules. Go over here, and then let's create a new virtual environment. So virtual env, venv. So we'll want to install a few different modules here. So venv bin activate. We'll need a module called Python decouple. So pip3 install Python decouple. That's going to allow us to keep our parameters separate in that .env file and very easily access them later on. We're also going to need Python Binance. We'll also need pandas. I'm also going to be using pandas TA to calculate the RSI values. So pandas TA. And I think that's it in terms of external modules that we need to download. So now that that's done, we can actually go ahead and get started. The first thing that you'll want to do really is to go and just sign up here on the testnet.binance.vision website. You can just log in here with a GitHub account, and it will allow you to generate some API keys. Like I said before, you don't need a Binance account. You can just go to this website and log in with any GitHub account that you want, and it will generate a set of keys for you on the spot test network with a variety of different assets already loaded on it. So I'll show you what that looks like in a second, but just go here and you'll get an API key and a secret key. Then in the same folder as where you're going to put your bot, create this .env folder here, and then open it with your text editor and just do API key equals your API key, secret key equals the secret key. Once you've done that, we can now actually start using Python. So let's do vim, we'll do tutorial.py is what I'll call it. And then from decouple, import config. So this is our Python decouple module. We're going to be using that in just a second. And then from Binance.client, import client. Obviously, that's going to be used to interface with Binance. So I'll just go ahead and briefly show how the decouple module works here. So we can print config, and then you just give the name of it. So API_key. Give that as a string. So if I go back to our .env folder here, you can see that this variable is called API key. So if I just copy and paste that into here, it will give us that value. So if I print that, you can see it's just printing out the API key here. So that's all that's going on with Python decouple. Again, it's just a security measure to make sure you're not leaving your API keys in places where people can find them. So let's go ahead and set up our Python Binance client here. So client is equal to client with a capital C. And then we give the API key and the secret key. So config is going to be the API key, config, secret key. And then we also need one extra parameter here, and that's just going to be testnet equals true. If you want to trade live, you just have to remove this testnet equals true here, and obviously generate some API keys for actual Binance.com, and it will work. If you're trading on Binance.us or any other top-level domain, you have to set the top-level domain here to be .us or just US. That's on the documentation. You can look that up later on. But basically, all you have to do if you want to convert this entire bot to live trading, just get rid of testnet equals true here and generate some new API keys. Let's go ahead and look inside our testnet account here. So let's pull up and we'll say balance is equal to client.get_assets_balance. Then you can just give the asset that you want here. So asset is equal to, we'll say BTC. And then we'll print balance. So you can see here, we've got 1.11 Bitcoin in our testnet account. Do note that they pretty regularly reset the account value every month or so. So if one day you wake up and the testnet account has got less than it had before in it, that's just because they regularly reset the values. Okay, so we can see our clients working here. We can connect to the testnet. We can check how much is in our account. Let's go ahead and start gathering some data now. So I'm just going to create a function for this because we're going to be using it quite a lot, and just having it wrapped up in a nice function is easier. And I'm just going to call it fetch clients. Now, clients is the word that Binance uses for candlestick data. I'm not sure why they use that. None of the other exchanges I've used use clients, but Binance does, so that's what we're going to be using. And what we're going to pass in is the asset. So whether it's BTC USD, ETH USD, we're going to fetch the clients for that particular asset. So the next line here, we'll do clients is equal to client.get_historical_clients. We'll pass in the asset that we want, which in our case is just going to be Bitcoin. Then we have to pass in the time interval. So there are a few of these built in to Python Binance. You can again look those up on the documentation. I'm going to be using the 1 minute. So it's client.cline, all caps, cline underscore interval underscore 1 minute. All of the other ones basically follow this format, so it should be relatively easy to guess, but if not, you can find a list of them on the documentation. The final parameter here that we'll have to provide is how much data we want to gather. So the way you do this, you just say how long ago do you want to gather the data from. So I'm going to say 1 hour ago UTC. Again, fairly strange way of doing this in Binance, but that's just how it goes. So let's go ahead and just print out that client data here, and we'll see what we get. So if I call fetch underscore clients and with BTC USDT, make sure you include the T there because Binance doesn't actually have a BTC USD pair. It just trades Tether against BTC or USDC. So if we run this, I've misspelt historical here, historical. We can see it's certainly getting something here. So it's getting a list of lists. So you can see this is one list here, this is another list, so on and so forth. And essentially each list in this list of lists represents an individual candlestick. So let's just go ahead and print out, say, the first one here. So we'll just print out the first element in this list of lists. If you head on over to the Binance API documentation, it's on their GitHub here, you can see what format the clients are actually in. So you've got open time, open, high, low, close, volume, loads of other stuff that we don't really need. The only information I'm really interested in is the open time and the close value. That's what I'm going to be using to actually trade on. Obviously, you can trade on any of these factors that you want. So let's go ahead and just extract those particular columns. So we want the open here, and then I believe close is the 5th column. So 1, 2, 3, 4, this one here. So let's go ahead and do that. And while we're at it, we'll also convert things into a data frame. So let's firstly do something like clients is equal to, then we'll do a list comprehension here. So we want to convert every element of this list into a different kind of list. And we'll just say we want the first element and we want the 5th element for X in clients. So all this list comprehension does, goes through every element of clients, assigns that to X, and then we just index the first element and the 5th element. And we put that in a new list. So if we print this out again, we'll see that we're now just getting the open time and the closing value, basically. So this is a lot easier to read and comprehend for us. In fact, while we're at it, I might go ahead and convert this to a float. So we can see here it's actually in a string format, which obviously if we want to do numerical calculations on it isn't exactly great. So while we're at it, I'll just convert this to a float here. So I'll just grab a float like that, and that should solve some of our problems. There we go. You can see it's now an actual number format rather than a string. So we'll go ahead, wrap this up as a pandas data frame here, since that's something that pandas TA is going to be able to consume, which is our library for technical analysis here. So we'll say clients is equal to pd.dataframe. We'll pass in clients, which is just our list of lists here containing our time and price values. And then we'll set the columns. That's going to be equal to time and price. Once we've done that, let's print it out again just to check what's happening. We haven't imported pandas. Let's go ahead and do that. So there you go. We can see this is a much easier to read format, just having the time and price there. as opposed to the list of lists, which can get a little confusing. The final thing I'm going to do to this client data here is I'm just going to convert the time column there to be in date time format as opposed to just an integer. Mainly so it's more human readable, but also so that Pandas actually recognizes it as a date time format. So to do that, we just specify the time column here. And then we'll set that equal to bd.to_date time. We again pass in the time value. And then we also have to pass in the unit here. So what format is the time in? So we saw that the time was represented as a number, which is the amount of time since the 1st of January 1970. But is it in milliseconds? Is it in seconds? Is it in nanoseconds? I believe for us it's in milliseconds. So we'll use ms here for milliseconds, and that should work if we print it out. We can see that we actually get today's date here. If not, you can just check and compare, maybe use seconds or nanoseconds or something else and it'll work. Finally, all we need to do is just return clients. So we've done everything that we actually need in order to gather our client data here, our candlestick data. So that's the first part of the bot actually finished. I think the next function here that it makes sense to create is to actually get our RSI value. So in order to do that, we have to import pandas TA here. So pandas_TA as TA. And then we'll create our function here. So we'll call it get_RSI, pass in the asset name here. And it's going to be pretty simple. Firstly, we just get the clients using our function we've just made. So clients is equal to fetch_clients asset. And then we just need to use pandas TA to actually convert that into an RSI data frame. So clients RSI is going to be equal to ta.rsi. We then need to provide the closing price, which, if you remember, is just the price column in our clients data frame. So clients price. And then we want to specify the length of our RSI. We used a window length of 14 before, so I'm just going to use that. So length is equal to 14. And then finally, we'll print it out here just to see what it looks like. So if I just call get_RSI here with BTC USDT, we'll see what it returns. So pandas TA, if you haven't seen it before, interfaces quite nicely with pandas, hence the name. So we just have this column here called RSI. The first 13 or so elements won't have anything just because we used a window length of 14. And then from there on, we have the RSI value for the 1 minute candles, given that these are 1 minute intervals. So that's great. For our get RSI function here, I'm just actually going to return the final RSI value. So what is the RSI value currently on the current candle? In order to do that, we'll just do return clients RSI .eloc for integer location -1. So basically, what's the final RSI here? And so if I print that out, let's print it out a couple of times here to see what happens. As you can see there, it's updating in quasi real time. It's not waiting a full minute before it gets the next value, which is good for us. It means that we're getting the most up-to-date RSI information. No matter what kind of period we refresh on, we're always going to get the most up-to-date RSI. So we've got our method for getting RSI data here. I think the next function that it makes sense to build would be the one to create an account. So I'll go ahead and do that now. I'll just make sure I've deleted the old one first. So we'll delete this one. And then we'll make a function called create account. So if you remember, the function of this is basically just to make a JSON file and note whether we're actually buying right now or we're selling and what assets we actually have on hand right now. This is just so it doesn't go on a buying spree and buys every single time we check the values. So we'll just make a dictionary here called account, and it's going to be pretty simple. We've got is_buying. That's going to be true to start with, right? Because when you start up the account, you're in the market to buy stuff. And then we'll create our assets here. And that's just going to be an empty dictionary because currently it doesn't have anything. And we'll close that out. Then what we'll do is we'll just write that to disk. So we'll do with open. And we'll just call it bots_account.json. We'll be in writing mode, so we're just going to overwrite anything that currently exists as f. All we have to do is f.write, and then we're going to convert this dictionary here into a JSON format, so it actually writes down as JSON. So to do that, we'll call json.dumps. Make sure you put the s on the end there. That's quite important, otherwise we'll call a slightly different JSON function, and we'll put account in there. Now we need to import JSON, otherwise that won't work. And then finally we'll just call it down here just to make sure it's actually functioning. So create_account. It would help if I could spell account. There we go. So if I just open up this file here, you can see we've got a bot account and it looks good to me. So now that we've got that, we can start to plot out some of our actual trading logic here. So actual main loop of our program that's going to run over and over again. We'll still need to create a fair few more functions just to actually perform some other jobs that we need. But we can plot out how things are actually going to work. So first what we need is we just need an initial RSI value. So what I'm going to do is I'm just going to set the value RSI is equal to get_RSI. And then we need to put our asset name in here. So I'm just going to put a variable in here called asset. And then at the beginning of the document, we'll just create a variable called asset. And that's going to be equal to BTC USDT. Just saves me some typing later on. And then we're also going to need a variable called old RSI. So the reason I'm using RSI and old RSI is so that we can check whether we've had a crossover of a specific RSI value. So for example, if we're wanting to check whether the RSI has crossed below, say, 25 in the last check, we compare RSI. So if RSI is below 25, but old RSI is above 25, we know we've had a crossover on that particular check, so we'll trigger a buy signal. Again, this is just how my bot's going to work. You can obviously mess with this a little bit. So I'm just going to set that to RSI for now. Obviously, it will get updated as we progress through the loop. For the actual bot loop here, I'm just going to have while true. So this is going to run infinitely, basically. And then around the whole section of code, we're going to have a try and except. Now, strictly using try and except like this is not particularly recommended, but given that this is the outermost layer of our program, and we'll be logging all of our errors here, it's fine for such a simple program. If you want to, you can go through and you can catch specific exceptions here in this except section. You could add more exceptions. That would be a slightly fancier way of doing things, but again, we're just looking for something simple here. So I'll just put a note to ourselves here to log error. When we actually write our logging function, I'll be able to pass that in. So in our try section here, which is where we're going to be actually writing our trading logic, the first thing that we need to do is we need to check if an account exists. So if not os.path.exists bot_account.json. So we're just using the OS module here, which comes default with Python. And we're checking if botaccount.json exists. This is a relative path, so it'll only check the current folder. If you've got your bot account saved to a different folder, you'll have to pass in either a full path or a relative path to that particular file. So if it doesn't exist, let's create an account. Now we'll have to import OS here, otherwise it'll complain at me. Again, built-in Python module, so it should run just fine. Now that we've checked if the account exists, we can actually open it up. So with open bot accounts.json as f, account is equal to json.loadf. So I'm just using the JSON library to load the file there. We can print out account here, and you'll just to check it's working. Now this isn't an infinite while loop here, so it does keep printing forever. You can use Control-C to stop it. Although actually in this case it may have been ill-advised by myself there. It doesn't seem to be wanting to stop, so I'm just going to kill the terminal here. And then open it back up. And for now we'll just put sys.exit in here. If we don't do that, we're going to get stuck in that infinite loop and we're not going to be able to get out even with Control-C. So I'll just import sys. We'll change that later on. But just for now, just to make sure we can actually exit out the program. If I press Control-C, it actually lets us quit now, which is nice. So we've got all the account stuff sorted. We can now go ahead and add in a little bit of our trading logic here. So first thing we'll want to do is we want to update our values of RSI to whatever it currently happens to be. So to do that, we first set old RSI equal to RSI, and then we update the value of RSI. So we'll say get underscore RSI asset. So that's just going to update old RSI and RSI to the newest values. And then we want to check if we're buying. So if account is underscore buying. So that's going to look in our JSON file. It's going to look at this value. If it's true, then we do this. If not, then do nothing. Or rather, look for our sell conditions. So if we are buying, we want to see if our RSI has crossed a certain threshold. So what we can do is we can say if RSI is less than our entry point and old RSI is greater than the entry point, that means we've just crossed that threshold of the entry point. So I'll just write a note in here and I'll just say do trade. We haven't actually written the code that does that yet, but when we do, we'll write it in there. And then if account is not buying, so if it's false, well, we now want to look for our sell conditions. So if RSI is greater than exit, and old RSI is less than exit. So this is just checking whether we've crossed our exit threshold while the RSI is moving upwards. Again, we'll do the trade here, but we haven't written the code for it. And then at the end here, just before we sleep, we'll print out the value of RSI. So this is pretty much the structure of our entire trading process. All we need to do is we just need to create a logging function and a function to do the trades. And this project will be pretty much complete. So I'll start off with the logging function since that's going to be a little bit easier for us. So we'll first off import date time. We'll need that in order to log the timestamp of the specific event when it occurs. And we'll go over here and we'll just create a log function. So log, and it'll just take a message as a string. We'll print it out to the user so that we can see what's going on. So an F string here, just so that we can add variables in there. So log and then message. So I'll just put the message in that string and we can print it out. We then need to create a folder to put the logs in if one doesn't exist. So if not os.path.isdir, so is directory, we'll check for logs. If it doesn't exist, let's go ahead and create one with os.makedir. Then let's grab the current time. So what is the time right now? Pretty easy to get. So you do now is equal to datetime.datetime.now. I'll print this out just to make things a bit more explicit here. And then I'll just log something random here. So log hello. If we run that, you can see, well, firstly, it prints out log hello, and secondly, it also prints out a timestamp here for us, right down to the millisecond, or the nanosecond even. So what I'm going to do is I'm going to split this into a time and a date. So let's get the date first. We'll say today is equal to now dot, then we use string format time. So this is a function built into Python datetime module, and it essentially lets you format the date time as a string however you want. So you do %Y, and then we want a dash, %m for month, lowercase m, and then %d for the day here. And I can go ahead and print that out just to show you again. So if I print today, you can see it just gets the year, the month, and the day. So that's great. Let's do the exact same thing, except we'll get the time. So I'll just copy and paste that, and we'll get the time. And instead of year, month, day, obviously that's going to be hour, minute, second. So it's capital H, capital M, and capital S. That'll get you the time. I won't print that out because it should be fairly obvious how that works now. And then finally, all we have to do is actually save that to disk, so actually write that out into a file. So I'm going to use with open, then pass in an F string, and we'll save that to a file called logs/, so it's going to be in the logs folder, and then it's just going to be called today. Whatever the time is today, so whatever the string value of this is, that's what the log folder is going to be called. So we'll have a new log folder for every day. This can be very useful if your log files are really long, or if one happens to get corrupted because of a power outage or something. It's really helpful to have logs on multiple days, just so you can back them up and whatever. So it's going to be logs/today, and then .txt on the end there. The mode which we're going to be writing to it is going to be A+. So that's append plus, which means that it will also write the file if a file doesn't exist. But if it does, it will just append to the end of the file. And we'll call that log_file. And then all we have to do to write to this is we say log_file.write. Yet another F string here. And we'll put the time in. Then a colon. Then the message that we want to write. So the original message that was logged. And then it's important to do /n on the end here. Now, what that does is it just makes a new line. So if you didn't include the /n, all of these would be appended on the same line. It would just be one really long line in the file. But if you put the -n here, it'll mean that there'll be a new line character. So everything will be all on one line each, which is what we want. So that's the logging function written. I'm just going to put that in here. So instead of our sys.exit, we'll actually log our error here. So in order to write that out, all we have to do is we have to change this except a little bit. So we're actually going to grab the exception itself. So what exception is called as E. And then we're going to print it out. So we'll do log and then error in capital letters, and then we'll convert the error here to a string, and we'll add that in. So this should work now. Obviously, it's not happy that entry is not defined here, so that's why it's printing out all these errors, but at least it means our error log is working here, although we need a space between the two. It also means that Control-C now works without having to do that trick with the sys.exit, which is great. It means we can actually escape out of our infinite loop. So let's go ahead and define entry and exit here, otherwise it's just going to complain at us. So let's go to the top, and we'll say entry is equal to 25. I think that was the value that we discovered was optimal. And exit is going to be equal to 74 or something like that. Obviously, you can just really easily mess with those if you want to change them to optimize them, check out different bots. So the bot's really coming together here. We basically have just the trading functions to implement here. So we've got all of our logic in place. We just need a function that's going to actually send the trade to Binance itself. And thankfully with Python Binance, that's really, really simple. So let's go ahead and just write that function. So we'll go up here just so we've got some space. And we'll call it do trade. So does what it says on the tin. And it's going to take in quite a few different parameters here because obviously we want to make this multifunctional. We want it to be able to both buy and sell. And we also want it to update the account file after we've bought or sold. So we're going to take in account so it can update the account. It's going to take in client so that it can connect to the Binance client itself so it can send messages to Binance. It's going to take the asset name so that it can log that in the trade log. It's going to take the side of the trade, so buy or sell. And we're also going to take the quantity that we're actually wanting to buy or sell. So quite a few parameters there, but don't worry, we'll get it sorted. So let's start off and think about what's going to happen if we're buying. So if side is equal to buy, let's trigger a market buy. Now, obviously, you can mess around with limit orders and that kind of thing, but again, I want to keep things simple in this tutorial, so we're just going to do a market buy. Now, to do that in Python Binance, pretty easy. We just do order is equal to client dot order underscore market underscore buy. For some reason, there are two separate functions for buying and selling. It's not just a parameter. I'm not sure why that is, but nonetheless it is this way, so we have to deal with it. We pass in the symbol here. Now that's just going to be our asset. And then we want the quantity, which is obviously just going to be our quantity variable. And that's pretty much it. That's how you submit a market order. It's just pretty much one line of code. Python Binance makes this really easy for us. So after we've bought something, well, now we want to set is buying to be false because we're now actually looking to sell. So let's do that. We'll set the variable of is underscore buying, and we'll set that equal to false. All we need to do is we need to do the inverse now for selling. So let's do that. So else side is equal to sell because we're only going to put buy and sell values in there. I think I'll just copy and paste this and then hopefully remember to change everything. So instead of market underscore buy, it's just market underscore sell, same parameters. And then obviously we want to change is buying equal to true here. So this function will actually work to do our trades, but we need to add a little bit more to it just to make sure that if our order doesn't execute immediately, we can actually wait until it's filled and then we can log the value which it got filled at and that kind of thing. So what I'll do is I'll just print out the value of order just so we can see what's going on. And then I'll call do trade over here. So if I just comment out the rest of the code here with these triple quotes, I can go over here and we'll call do trade, do underscore trade. For account, I'll just pass in an empty dictionary. It doesn't matter. We're just testing here. Client, well, we'll just pass in client. Asset is going to be assets. Side, well, we'll just buy for now, just to check that things are working. And quantity, we'll say like 0.01 Bitcoin. So if I just run that, it'll run once. And this is our order object, which we get back from Binance after the order's gone through. It'll be pretty much the exact same for the live API. So the interesting things that we want are the status here. So we can see it's actually filled. It only took a couple of seconds there, maybe not even 1 second to fill. And then the next thing we want to look at is fills here, which is a list of all the fills. So for example, we bought 0.002 Bitcoin for this price. And we also bought another 0.007 for this price. So we'll want to average it out across the different fills. This is just because we did a market order rather than a limit order. So we'll want to condense this into just one value basically, rather than having to print out the value of every single fill, although you're very welcome to do that if you prefer. So the first thing that we'll want to do is we'll want to make sure our order's actually filled before we start logging anything. So to do that, I'm going to go in here and we'll say order underscore ID is equal to order ID. So we'll just grab the order ID, fairly simple. And then we'll start up a while loop and we'll say while order status is not equal to filled. So while the order is not filled, let's check if it is filled. That's essentially what we're going to do here. So we'll actually reassign the value of order here to be equal to client.get underscore order. Symbol is equal to asset. And the order ID is equal to the order ID that we just got there. So order underscore ID. And then we'll do a time.sleep here just to make sure we're not spamming the Binance API and we don't get banned or anything like that. So what this little piece of code will do is it will ensure that everything gets filled. You might want to add some error catching here just in case, if it doesn't get filled after 30 seconds, then cancel the trade or something like that. But for our purposes, this is going to work great, especially because we're on the testnet and you rarely encounter those kind of fill errors. So now every order that we put through should be filled. So that's great. Our orders are actually going through, they're getting filled. All we need to do is we need to calculate how much we actually paid for the Bitcoin that we bought. Now we're going to do this by using a list comprehension on fills here. So we're going to go through, we're going to multiply the price by the quantity and then add them all up. So fairly simple. That's just going to how we calculate the price. You'll notice that commission's 0 here. Now that's because we're on the testnet. I believe you can set that to be specific values by going into the client settings. That's up to you if you want to do that in your forward testing or not, or if you want to do that afterwards after we've got the trade data. Since Binance uses a fixed percentage as its commission, it's fairly easy to add that in afterwards if you want. Again, that's up to you. So in order to calculate the price paid, like I said, we're going to do a list comprehension. So price underscore paid. Well, let's start our list here. And we'll make sure everything's in the float values. So as we saw earlier, sometimes Python returns things as string values. So we want to make sure everything's as a float so that we can actually multiply and divide and whatever other calculations we want to do. So we're going to take each fill in that list and we'll get the price here. And then we'll multiply that by the quantity. So float, fill, quantity. And we'll do that for every fill in the order. So order fills. So I hope that makes sense. List comprehensions can be a bit scary sometimes. And then we'll just take the sum of all of that. So we go through that list of fills, we take the price, we multiply it by the quantity, we do that for all of them, and then we add it up. And that'll give us the total price paid. I can print it out here. Let's put another order through. So you can see, in this case, I think we had a few different fills. So fills, we bought a certain amount of Bitcoin at this price, and then a certain amount at this price. And if we take the average of that, we get that we bought our 0.01 Bitcoin for $400 and pretty much $27 there. So that's working great. We now need to actually log that data. So I'm just going to put a comment in here because we don't actually have this capability yet. So log trade. You could just put that in your regular log, but I'm going to build a specific trade logger just so that we have things in a nice CSV format for data analysis. And then we'll want to actually save down our bot account file. So if you remember, we changed the is buying value to be true or false. So we just want to save that back down to disk so that next time, if we bought, then we're now going to be looking to sell. If we sold, we're going to be looking to bought. So open bot underscore account.json w for write, so we're just going to overwrite any file that happens to be there as f. And then, same as we did before, f.write json.dumps, make sure you remember the s, and then account. So if we now enter our do trade information into here, we'll be pretty much ready to go. So in here, instead of pass, we'll actually buy something. So we'll do _trade, we'll pass in our account, we'll pass in the client, we'll pass in the assets, we're going to be buying, and the quantity is going to be 0.01. We'll do the same thing over here, except we're going to be selling. So let's just run this a few times and see what happens. So every 10 seconds, it's going to print out the current value of account and the RSI value here. Now, obviously, we're not forced to get a crossover during this testing period, but I'm just checking that things are actually functioning. So the final piece of this bot that we just need to write here and will be completely finished is the trade log, so that we're actually logging our trades to file. It's going to be a fairly easy function. It's going to be somewhat similar to our logging function over here. So I'll just write it below here so they're in the same place. And we'll say trade _log. It's going to take the symbol that we're trading. It's going to take the side, so buy or sell, the price, and the amount. So how much were we selling or buying? The first thing that we'll do is just write it out to the regular log. That means it'll also get printed to the screen, so if you're just checking up on the bot, you'll be able to see whether it's bought or sold recently. That's just going to be an F string, and we'll say side amount, sim, and then for price per. Obviously, you can write that out however you want. And then we need to do pretty much the same thing we did over here with a log. So we need to check that the logs folder actually exists, or rather the trades folder exists. Remember to change this to trades and this to trades. If it doesn't exist, make a folder called trades. After we've checked that the folder exists and we've got the date and time, we now want to check whether the actual trades file exists for that particular day. So if not, os.path.isFile f trades/today.csv. Very similar to the logs that we did before. So if it doesn't exist, let's create it, and we'll also create the column headers. So with open f trades/today. Make sure this is in an F string, otherwise you'll have problems later on. .csv will be in writing mode, so we want to overwrite anything that currently exists. If for some reason we did have a file in there with that name, as trade file. And then let's write to that trade file. What are we going to write? Well, we just want to write our column headers in basically. So symbol, side, amount, and price. And then make sure you put a /n on the end so that there's a new line. So the reason that we do this compared to the log file is that the log file doesn't need a header. Each file just sort of stands on its own. Whereas in the trades file, we want to actually label our columns and which order they're in and that kind of thing. So if the file doesn't exist, then put our header in. If it does exist, then we just want to write the trade information down. So that's fairly easy to do. I'll just grab this over here and we'll basically copy it, indent it in a little bit, and instead of writing in W mode, we'll be writing A+ for append. And instead of writing sim side amount price, we'll actually write in the sim side amount and price. So basically just make this an F string and surround everything in curly brackets. Again, make sure you've got the new line break on the end, otherwise bad things will happen and you'll have everything on one line. Now that we've finished the trade log function here, let's make sure we actually call it when we make a trade. So if you remember, we put a comment in here saying that we were going to log the trade. Let's actually do that now. So we'll call trade log, get rid of that colon at the end. I believe we called it asset inside this function. And then side, price, paid here, and then quantity. So asset, we just get that through this function. So if we go up to the top here, we can see we've passed in asset, side, and quantity. So we're just relaying those into the logging function down here. So asset, side, and quantity. And then price paid, we calculated from our list comprehension overall, the fills here. So we just pass that in as the price paid, and therefore our bot will actually do some trade logging. If you forget to put this line in, you won't have an actual record of your trades, so I highly recommend that you do so. So that is actually it, unless there are any horrific spelling errors that I've made. This is all of the code that we actually need to have a fully functioning trading bot that connects to the Binance testnet. As I said before, if you wanted to run this bot live, pretty easy to do. You just have to take testnet equals true off and put your actual API and secret key into the config once you're happy with the performance of the paper trading bot, which we've built here. So I'll run this one last time here just to make sure there's no syntax errors or anything. It seems to be functioning fine. In the next section, I'll be showing you how to deploy this to a cloud server, just so that you don't have to keep your home machine running all the time and, if your internet goes out or something like that. So look forward to that in the next section, and I'll see you there. In this section, I'll be showing you how to deploy the bot that we've just made on DigitalOcean, which is a cloud service provider similar to Azure or Google Cloud or AWS, except the interface is a lot simpler and it's much easier to just quickly get up and running rather than dealing with the somewhat cumbersome interfaces that Azure and AWS have. It's a lot less intimidating and easier to make something that's very simple. We don't need anything particularly fancy for this project. All we're doing is we're renting a virtual machine, so we're renting computing space on one of their servers, and we're just leveraging the fact that their facilities have pretty much 100% uptime with constant internet access. Whereas if we were to try and run the bot on our residential internet, we might be prone to cutouts, which would mess with the running of the bot, you'd miss trades, etc., etc. Not particularly great, and personally I wouldn't want to have to constantly manage a 100% on computer all the time in my house. So it's much easier to just rent a server from DigitalOcean or similar. The steps will be very similar no matter which cloud service provider that you use. You'll just have to do a bit more figuring out with the interface. I know Google Cloud has something like a $200 free trial, so you could use that if you don't want to spend any money. All of the cloud providers bill to the second or the minute, so the cost of doing this tutorial will be something like 5 cents if you follow along. So without further ado, let's get into this section and deploy our bot to DigitalOcean. So I'll start by just introducing you to the DigitalOcean website here. All you have to do is just sign up for an account. You can log in with GitHub or Google. When you do that, you'll be faced with something that looks a bit like this. So you can just create a new project on the side here. Don't worry about all this crazy stuff. We don't need any of that. All we want is a droplet, which is basically their name for virtual machines. So we just want to create a new droplet. Click Create Droplet. You can pick your distribution that you'd like. I'm going to choose Ubuntu. That's the most widely used Linux distribution. If you know what you're doing on Linux, you can obviously feel free to pick any other variation that you like. CPU, just pick the most basic one unless you're doing something crazy. I'm just going to pick the very cheapest option here. That'll be more than enough for the bot that we've created. You really don't need anything more fancy than that. Obviously, if you've got some crazy machine learning model that needs insane computing power, you might be more up here or picking something like the CPU optimized one. But for us, we just need this $5 a month one, and that will more than cover our needs. We don't really need any block storage. We don't have a database on this bot or anything. There's no real need for that. The data center region, now ideally you'll want to pick the one that is closest to your exchange if you care about execution times. So if this bot were trading equities, say on the New York Stock Exchange, we might want to pick the New York data center here. I'm not actually sure where the Binance servers are, so I'm just going to set mine in London. I believe they all cost the same anyway. So once we've selected our location, we then want to think about authentication. So you can do this with SSH keys if you care more about security. I'm just going to set a password that'll be secure enough for our purposes. Obviously, depending on what kind of stuff you've got stored on the server, if you're using a real API keys, you want to be careful about the security of the password that you're using. I'm just going to generate a password here using this fancy command line tool. So I'll just grab this one here and I'll just very securely here copy and paste it into a notepad for further use. So copy and paste this into here. That meets all the security requirements. We don't need any of this stuff really. You can pick a host name if you want. I'm just going to leave it as this one. I don't think we need anything else. You can assign it to a project. So I'm just going to assign it to this bot project that I created. Obviously, you can see this is where I host my website. This is where I host my crypto nodes. DigitalOcean is quite useful for little projects like that. So I think that's pretty much all the configuration that we need. Pick the cheapest one. Pick the data center either closest to you for convenience and ping reasons, or closest to your exchange if you care about latency. Pick a password, make it strong. You can use SSH keys if you want, that is more secure. And I think that's pretty much it. So if I click create droplet here, that will make our server for us. It'll also start billing us at 0.7 cents an hour or whatever it happened to be. So I'll wait a few seconds here for this to finish. So we can see it's got a green thing here. It looks like it's actually gone and booted up for us. So don't worry about any of this stuff down here. We don't need it. All you need to do is just take note of the IP here. So I'm going to copy this. And this is what we're going to be using to actually connect to the server. In order to do that, what I'm going to do is I'm going to pull up a terminal window here. Now, this will work on Linux, Mac, and Windows 10 and above. If you're on a different version of Windows or for some reason it's not working for you, you can try out PuTTY and this should work. So if you go to putty.org and download it, it's just a graphical interface for SSH, which is the protocol that we use to connect to the server. Sometimes Windows can behave a little strange with SSH, so you might want to try out PuTTY, but first I'd recommend just trying the command line and see if that works for you. But PuTTY is an option, plenty of tutorials online. So anyway, let's get back to this. So pull up a terminal or your PuTTY window. Then we'll want to type SSH, so that's the command to create a secure shell here. And then I believe DigitalOcean just lets us log in as root, which is not the most secure thing in the world, but so SSH root at, and then your IP address. So if you're on PuTTY, this is the username that you'll use, root at this IP, or you can just use the IP, type in the user later. So if I connect, it'll give me this thing. It just means I haven't connected it to before. I trust it, so yes. Then we need to enter the password, which I have here in this notepad. We can copy and paste it in. And there we go. We're actually on the server now. So if you're not too familiar with how Linux works, I'll try and explain some of the commands as I go along. We're not really going to be doing an awful lot on the server itself, just because our program is so simple. Our bot is literally a single Python file. So we're on the server here, but we need to actually send our Python file over to the server. Now, you could do this just by copying and pasting. So, for example, I could create a file here using Vim. So Vim is like a text editor like Notepad. So I could say vim test.py, and then I could just copy and paste my entire code in here. Now, you can do that. It's just not the most reliable way of doing things, and it's a bit inconvenient. We'll want to transfer using SFTP, so Secure File Transfer Protocol. Now, you can download a client to do this for you, like FileZilla. So that's what I'm going to use here. I believe FileZilla is cross-platform, so we shouldn't have any problems no matter which OS you're on, whether you're on Linux, Mac, or Windows. All you need to do is enter your host up here, so that will be our IP address. I'll go grab that from here. So enter the host, the username is root, and then the password will just be the one that you made. You want to make sure that you put the correct port in here. I was having trouble there because I didn't put the port in. If I quick connect to it, it now gives us the same message that the SSH client gave us earlier. So it's just basically saying, we haven't connected to this server before. That's okay. I trust the host, so I'll click OK. So we're now connected in. All we need to do is, firstly, on the left-hand side here, we want to navigate to where your bot data is stored. So mine's just in this folder here. And then on the right-hand side, we don't really need to do anything because we're just going to dump it in the home directory. So let's put our bot code in there. So just drag it over. You can see it's now there. And then we'll also drag our .env folder over. So this is the file that contained our API keys, if you remember. So I think that's it in terms of transferring everything over. Obviously, if you're familiar with the command line version, you can use SFTP on there as well. But a client like FileZilla is multi-platform, so I thought I'd use that for the tutorial. So let's get back to our terminal window over here. And if I type ls, which essentially shows me all the files in the directory, or I do ls-a, which also shows me the hidden files. So a hidden file just means it's got a dot in front of it. We can see that I've got tutorial.py and I've got the .env file. So we've got everything that we need actually to start up the bot. Now, a few things are going to happen. So if I just try starting it here, so we call python3 tutorial.py. It's firstly not going to work because we don't have the correct Python modules installed. So let's go ahead and install them all. So if we just check in here, we need Python decouple, we need Python Binance, we need pandas, and pandas TA. That's all the modules that we need. So we should be able to install those with pip, like pip3 install Python decouple, Python Binance, pandas TA. So that should just install everything straight onto the server. We don't really need to bother too much with virtual environments because we're only going to be running this one thing on the server. So pip isn't actually installed on this server. This is something you might often encounter when booting up Ubuntu from scratch like we are here. Oftentimes things like pip aren't even installed. So it gives us a helpful command here that we can use to install it. So you can think of apt a bit like pip for Ubuntu. So it goes and grabs the packages that we need. So if I do apt install python 3 pip, that should work. Just click yes to say that we agree, and that'll actually install pip for us. So it looks like it's struggling to find the package here. So it's suggesting that we run apt get update. So let's do that to update the package directories so that it knows actually where to find pip. And then if you click the up arrow on your keyboard, you'll be able to scroll through the commands that we've previously typed in, so we don't have to type them in all over again. If I now try and install pip, we can see that the progress bar is actually going here. It's actually installing something. Now that pip's installed, we can finally call pip3 install python decouple. Do note that I am calling pip3 here. This is just the way Ubuntu works from what I'm familiar with. You have to call specifically the version of Python that you want. If you just use pip, it'll often just install the Python 2 versions of the packages. So call pip3 to be safe. And then we just install all of these different packages. The internet speeds are pretty crazy in these virtual machines because they're just hooked directly in by optical cable. So typically downloading and installing things is pretty speedy. So finally, we should actually be able to just create our bot here. So if we just do Python 3 tutorial.py, that should actually just start our bot as usual. Now, I'm just going to cancel out of that with Control-C. Obviously, that'll work, but the problem is with that approach, if I just call Python here, what happens when I close out my terminal is that this process also disappears. So that's the same problem that we had before, where we have to keep our machine open all the time. We really don't want that. What we can do instead is we can use something like tmux. There are a few different options here. You can use tmux, you can use screen, I think there are a few others. But basically what this lets us do is it lets us have a process running, and we can keep revisiting that process to check that it's still running, check that nothing's gone wrong. But the window will stay open, the session will stay open, even if we exit out of our terminal, even if we close our client machine down. We can try running it here. I suspect we'll need to install it. Nope, it actually comes as default apparently on Ubuntu. So if you didn't see that, I'll just exit out. So you just want to type the word tmux in. If you don't have it installed, you might have to do something like apt install tmux. But as it happens, it comes by default. So if you use tmux, nothing else, press enter, you get this screen, and you know that you've entered a tmux window because the bottom here should be green. So if we type ls, just to look at what's in our folder, you can see we're still actually in the root home directory here, and we're still in the same folder as our tutorial.py. Now when we run our Python 3 tutorial.py, if I exit out of this window here, the bot will keep on running no matter what. So I'm just going to show you that now. So we can see it's done what? It's done 2 cycles of the bot here. I'm just going to exit out here. So I'm going to close terminal. So let's open up another terminal here. So I've completely exited out of that one. I could turn off my machine, go to sleep, go do something else, and then come back and check on the bot later on. So I'm going to type in our SSH command again, and then the password that we need. And then all you need to do in order to get back to that screen is to type tmux attach. And there you go. You can see it's completed a few more cycles while we were away. Now, tmux itself can be, there's a lot of things to learn if you want to master it, but we can just create a new window here using Control-B, and then afterwards click C. That'll create a new window. And so using this new window, we can do things like check out the trades. So you can go into the trades folder, see what's happening, see what the logs have been posted, etc., etc. And if you don't feel comfortable accessing all of those on the Ubuntu terminal here, what you can actually do is you can just use FileZilla, and you can just pull it over to your home system and then have a look at it there if you don't feel comfortable using something like Vim. So you can just pull over the list of trades and then, open it up in something like Notepad or Excel or something similar. But this is the way I do it with the multiple tmux windows. If you want to go back to the other window, all you have to do is look at the number here and then press Control-B and then afterwards click 0 and you go back to it, or Control-B1 will take you to this other window. And so that's pretty much it in terms of bot deployment. This will just keep on going, it'll trade when necessary, and log all of our trades in this folder. We can drag it over after we've done, we can look at it on the terminal itself. So I'm going to leave this running for a couple of hours, maybe a day or two, and then I'll come back and we'll talk about some trade analysis. So just looking at how effective our strategy was, maybe where we could look at improvement in the future, and we can begin this whole cycle again where we go back to Backtrader, we optimize different parameters, and the cycle repeats itself until we eventually get some kind of winning strategy. So I hope you found this useful. Deploying to the cloud isn't as scary as it might seem, especially when you're using something like DigitalOcean, which makes this really, really easy for us. If you do have any problems, especially on Windows, do look up PuTTY and PuTTY tutorials. Sometimes the command line on Windows can be a bit dodgy, and whenever I'm using the Windows machine, I always use PuTTY, so that's up to you. You can try out both, see what works for you, and I'll see you in the next section where we start talking about our trade analysis. In this final section of the course, I'll be showing you how to do a bit of trade analysis, how to turn your list of trades into something where we can actually see the profit and loss of each individual trade, how well we're doing, we can calculate the win rate, we can filter the trades by how well they're doing, etc., etc. So we'll be doing that, and I'll give some final tips about how you can improve the bot in the future as an exercise to the reader. So without further ado, let's go ahead and get started. So the first thing we'll do here is we'll go and grab our trades. So if you remember from the previous section, we used FileZilla to connect to our VPS, and we can use that to basically use the SFTP protocol, but just more easily with a GUI interface. So we can grab our trades here. So if you just navigate to our trades folder, which should be in your root home directory, depends how you've set up your server. So you can see here we've got one for the 18th of January and the 19th of January. I've dragged those across over here. We can also pull across the logs as well, so that might be interesting to go through. And now we can do the analysis locally, which might be a bit easier for those of you who are not too used to Linux. The first thing that we might want to do with the logs, especially just after we've deployed the bot, is have a look through them and check that it's actually trading at the right time, that the execution logic is actually working. So we can see here we've got one at 9, 10, 42 seconds. So basically 10 past 9 at night. I believe this will be in server time, so it'll be UTC, so you have to convert that to your particular time zone. So if we look at the most recent ones, that was from the 18th, if we look at the 19th, we can see here that at about 9 a.m. it sold some Bitcoin for about $415. So what we're going to do is we can just go to the Binance Exchange here. We can pull up the RSI up here with the technical indicator. So go to wherever you hooked up your bot to. And we should be able to see that at about 9:08 a.m. we actually got to a sufficiently high RSI here for it to actually do some trades. So that's good. It means that the bot is behaving sanely. We haven't done anything where we have everything the wrong way around. Let's go ahead and look at where it bought. So it bought at about 3 a.m. So if we go back to 3 a.m., maybe over here. Yeah, so you can see, again, it's acting sensibly, and it's actually buying when the RSI is at an appropriate level. This is just something that's good to do, especially when you've just started off the bot, just as a bit of a sanity check to check that you've actually implemented the code correctly. In our case, one thing that you might want to look at is if we have these very sharp peaks here, sometimes the way our execution code works, it won't actually pick up these very sharp peaks because it only checks every 10 seconds. So if it's briefly above an RSI of 74, then it might not necessarily execute the buy order. So that's something you'll have to think about for yourself, whether you want your code to execute like that or not. But for our case, I'm pretty happy with how it's doing. Once we've got all that together, we can then append all of our trade files here. So if I open them up, you can see we've got the sim, side, amount, and price, and just different buys and sells. So I've just gone through and just put them into one text file here. The way I'm going to create this program to actually aggregate our trades is based off a few assumptions. One of them is that we just have buy, then sell, then buy, then sell. If your bot allows multiple buys and sells, this particular code won't work for you and you'll have to change ever so slightly. Similarly, if you're using multiple symbols, you'll also have to maybe go through a for loop for each individual symbol. The trades we have are basically in the most simple format that you could possibly have. We only have one symbol, and we buy, then we sell, then we buy, then we sell. We're always closing out a position. We're not doing anything with margin. All of those factors just make this more complicated, so I thought I'd just show a simple version in this tutorial. Let's go ahead and just whip something up in Python here. So we'll go vim tutorial.py. You'll need pandas installed for this, so import pandas as pd, but that's pretty much the only package that we'll actually be using. Let's go ahead and read in our trades data frame. So pd.read_csv, trades.csv, and then we'll print that out to make sure that it's working. So we can see here we've got basically two trades. I left this running overnight and it made 2 full trades, all for the same amount. So we're opening and then closing that position, opening, then closing that position. We aren't actually including commission in here, but you'll see our bot is actually performing abysmally at the minute, so I don't think it really matters either way with commission. But that's something you'd want to consider before taking a bot live. I'm then going to create a list here. So this list is going to be a list of all of our trades, and I'm going to represent a trade as a dictionary with the buy price, the sell price, the symbol, and the profit on that trade. That's how I'm going to encode the trade data here. All we need to do is we just need to go through this data frame, essentially 2 rows at a time. Now we can do that with the range function here. So if we do for x in range 0 to the length of the data frame, and we go in batches of 2. If I print out x here, you'll see what's happening. If I can spell length correctly here. I actually mean len. You can see it prints out 0, then 2. So what will happen is these indexes here are basically the indexes in the data frame where we're making purchases. So if we go 1 above that, so if we go to 1, that's where we have a sell. So I'll print that out just to show you. So what we can do is we can print df.eloc for integer location. So we just give, what is the index of it in integer format. So if we print out x here, and then we'll print out df.eloc x plus 1, you can see what's happening. So we print out first the buy, then the sell, then the buy, then the sell. And if I just print something between them here, just to make it a bit more obvious, you can see that we've essentially captured each trade in each individual run of this for loop. So now that we've got that, all we have to do is actually construct the trade. So I'm going to say the buy trade, so the trade in which we bought, that's going to be df.eloc x, as we discussed before. And then the sell trade is just going to be the same thing, but we have x plus 1 here. I'm going to get rid of these print statements. They just clog up the screen. And then from this, we can actually construct the trade dictionary. So let's create a trade. So this is going to be a representation of a trade. We'll create the sim here. So the sim is just going to be the symbol contained in either of these. We're not dealing with multiple sims, so it doesn't really matter which one we grab. So we can grab the symbol from the buy trade .sim. We need the buying price, so that's going to be buy price. That's going to be in the buy trade .price. We need the sell price. We can grab that from the sell trade. And then finally, we just need the profit. So that's going to be the sell trade minus the buy trade, basically. So the profit is going to be equal to sell trade.price minus buy trade.price. that should be good, really, for our trade dictionary here. I'll print it out so you can see what's happening. So I'll print buy trade, and then sell trade. And then finally, I'll print trade. So we've got the buying, so the entry into the position, then the exit out of the position, and then the trade that's created as a result. So it's grabbing the correct symbol, it's grabbing the buy price here, it's grabbing the sell price from the sell, and then the profit is just the difference of them. So we can see it's a negative number here. Same thing happens with this one. So everything seems to be working so far. All we really have to do here is append on each individual trade to the list of trades. So trades.append trade. So we're just going to add each individual trade onto the trades list. Now what we can do is we can just convert trades here to a data frame. So we say pd.dataframe trades. This is quite a useful trick. If you have a list of dictionaries, it's very easy to convert that into a data frame with pandas. If I print out trades here, it just gives us the list of trades in a very easy to read format that you can then do pretty much whatever you want with. So we've got the absolute profit here. I could calculate the percentage profit fairly easily here. So I can do trades and then let's just call it percent profit. And I could set that to be equal to trades profit divided by the buy price, trades buy price. And then just for completeness, we'll multiply that all by 100. So now we've got the percentage profit over here. And then, you can do things like you could filter by the percentage profit. So if we only wanted trades that were profitable, we could actually only print trades where trades profit is greater than 0. And if I finish my square bracket there. So we can see it's actually not printing anything because we had no profitable trades. But if we did, it would print out all of our profitable trades. We don't actually have the time of execution printed out in our trades. We don't record that in the trade log. That's something that you might want to add on to here, especially if you're doing analysis across multiple weeks or months even for the different trades. Can be a good idea just to keep a track of the timestamp at which the trade was taken. So you get the idea here, how you can analyze the trades. It's fairly easy to do once you wrap it all up in a pandas data frame. Much easier to manipulate the data rather than having it just in a raw CSV. And so that concludes our course here on algo trading in Python. I've shown you how you can gather data. We've gone through how we can do backtesting with VectorBT, hyperparameter optimization, how we can actually execute our trades in Python with the Binance Python API, how we can deploy our bot to a cloud server, and finally, we've just gone through how we can do some trade analysis. So that's the complete pipeline for how to do algo trading in Python. If you continue algo trading, you'll basically be repeating one of these 5 steps over and over and over again, and just plugging all the different modules together in different formats to figure out the optimal way for you to do your algo trading. If you want to work on expanding this bot, making it even better, there are a few things that come to mind. One of them would be creating your own local database on the VM which we host our bot on, and having the bot automatically pull its data from that local database rather than having to go back to Binance all the time. That just decreases the latency and obviously allows you to get in on trades that you wouldn't otherwise get with how slow it is to request the bars from Binance. You could also look at things like implementing WebSockets to stream data as it comes in, so stream the trades as it comes in directly from the Binance server. And that way you'll be first to know about any price changes and you can react to them very quickly and create your own candlesticks in the database itself using something like timescale or Postgres. Various options there. That would be an exercise that I'll leave to you, the reader. Maybe I make a tutorial on that at some point in the future. Another thing that you might want to think about is just having a more sophisticated deployment system. As it is, we literally just shoved a Python file on the server and pressed go. If you want to do this in a more sophisticated way, you might want to think about Docker deployment or maybe using one of the services offered by AWS or on DigitalOcean to just make things a bit more robust, implementing backups and that kind of thing. Having a managed database rather than managing your own, etc., etc. So I'll finish rambling here. I hope that you've learned a lot in this course and that it greatly helps you in your algo trading journey, wherever that may take you. And I'll see you in the next video.